In this demo, we are going to be looking at solubility and polarity. So polarity we've discussed before when we were talking about the structure of different chemical compounds. So polarity is based on the distribution of electrons and electronegativity. So the bigger the difference in electronegativity between two atoms, the greater the polarity. For an entire molecule, the polarity is determined by the type of bonds, polar or nonpolar, and also molecular geometry. So a molecule with nonpolar bonds is going to be nonpolar, but a molecule with polar bonds could be polar or nonpolar, depending on if the geometry of the molecule is going to cancel out dipoles. So if the geometry cancels, you end up getting a nonpolar molecule. If it doesn't, it will be polar. How this relates to solubility. Solubility is the ability of one substance to dissolve in another substance. So there's a general rule that we use called like dissolves like. Like dissolves like says that in order to dissolve, you need to form similar intermolecular forces. So similar polarity. So something that is polar will dissolve other polar substances. Something that is nonpolar will dissolve other nonpolar substances. But polar and nonpolar are not going to be soluble in one another. So we're going to be looking at three different substances. We have water, which water is a very common polar substance. We've looked at the structure of water before with its oxygen and hydrogen bonds, and the unequal distribution of electrons between that oxygen and hydrogen. Then we have styrofoam and acetone, who we're not going to talk about the structure of, but we're going to look at how these interact with water or with each other to determine their polarity. So first, here's my styrofoam. We're going to pour some water into this styrofoam. Now, if they're the same polarity, then the styrofoam is going to be dissolved by the water. But if they are different polarities, then it is not going to dissolve. So when we pour this water in, as a surprise to no one, the water has not dissolved the styrofoam cup. That's why we use it for drinks. It'll hold our water. So what does that mean about the polarity of this styrofoam cup? We know water is polar. So if the styrofoam was not dissolved, it means they're not the same type of polarity. So the styrofoam is nonpolar. I'm going to pour this water back now. All done with water. The next thing we're going to look at is the acetone. So acetone, I am now going to interact again with the styrofoam cup. So if acetone is polar, then we know it's not going to dissolve the styrofoam, just like water didn't. But if it's nonpolar, the same polarity as the styrofoam, then it's going to dissolve. Ooh. So you can see that bottom part of this cup is completely dissolved. We can go a little farther actually. I'm gonna break this down and just wow. There's no styrofoam cup anymore, right? So the acetone very much dissolved this styrofoam. The styrofoam was nonpolar, so that tells us the acetone was also nonpolar. Like dissolved like.